I think it's the obsession about the problem we are here to solve. I mean, David and I, we are like so mission driven. We were every weekend in the lab at Stanford. We were the one reopening the lab after COVID because we wanted to get these experiments done. It's just like an everyday obsession.
Hey everyone, I'm here with Sarah, who's the CEO and founder of Dioxycle, one of the first investments Gigascale Capital has done. Welcome, Sarah. Before we dive into your background, just tell us a little bit about what is Dioxycle and what problem are you solving?
We are developing breakthrough carbon utilization technologies. Most of the chemicals are made from fossil, and just the fact of making them emits a lot of process emissions. And so instead, what we are doing is that we are taking carbon emissions and using electricity, renewable electricity and water, turning that back into sustainable chemicals. And so the first product we are targeting is ethylene. It's the world's most used organic chemical. By displacing fossil fuel to make this product, we can actually displace over 1% of the world's emissions. So it's a gigantic opportunity in terms of carbon footprint, but it's also a big economic opportunity as well.
Just so people understand, ethylene, can you just give us a sense of what this chemical is and what it's used for?
It's like a precursor for all the plastics. When you think about plastic, you think about packaging. Also be thinking about, car interiors, PVC piping or PE piping, building material.
In this building.
Exactly, and even Windows frames and also textile fibers. So it's really in every carbon-based supply chain.
In traditional process, we're basically creating pollutants. We're creating CO2 and other pollutants as we sort of burn these fossil fuels or break them down. And you're kind of undoing that and doing it backwards and taking those pollutants as an input and then adding energy into it, renewable energy, so electricity, which can be made easily renewable, and using that to build these molecules back up into useful chemicals. Is that one way of describing it?
So it's really the process of taking out this oxygen from your CO2 molecule and actually recreating carbon-carbon bond. Electrochemistry is very powerful and elegant because it's laser focused. So it has this capacity of really targeting one specific reaction and creating the environment, the chemical environment, to actually stop at this CC bond and stay there.
There's this theme or this concept of precision medicine. How do you target the actual problem specifically rather than using broad spectrum, drugs or antibiotics or other things. This almost feels like precision chemistry. It's like rather than doing these big, dirty, gross bulk processes, it's like, hey, I need to make this chemical using these inputs. I'm going to do exactly that. And that's what you're doing in some way. Why can we do it now? Versus 10 years from now or 10 years ago? What is the sort of chain of events that got us to making this possible?
You really need to, to reach the energy efficiency we need to reach to make this economically viable. For the last 3 years, because we started 3 years ago, we've really focused on developing a novel technology that actually has the intrinsic potential of making this conversion possible and economically viable. We are at a point now where the state of the art has advanced enough so that we can start scaling up this technology.
Can you talk a little bit about how you become cost competitive with sort of these traditional dirty techniques for making this chemical?
Has to do with really asking ourselves the very hard questions. We really started with doing all the techno-economics to map out what are the hypotheses we need to be true so that this works. We entered a 3-year-long, let's say, tunnel, systematically addressing all the bottlenecks. We are still in the phase of scaling up, so we are not cost competitive at scale yet.
But the goal at the end of this is that at some reasonable scale, which isn't massive scale, that you will be able to deliver this chemical at a cheaper cost than traditional techniques.
Exactly. We have been focusing on developing that technology that can reach cost competitive or actually lower cost. A
green discount.
So I think, that was a good phrase to put it.
It's our favorite word. So I want to switch gears a little bit and let's talk about becoming an entrepreneur. You went and studied and you were a scientist, you got a PhD. Did you ever think when you were there you would be doing what you're doing now?
Well, 8 years ago, actually, I met David. David is a really brilliant chemist, and we looked at all these different problems, all the aspects of this technology and what it can solve, and got really passionate about applying this electrolysis technology to the conversion of carbon emissions. What got us to really transition from academia to a startup was first, perhaps a frustration of the scale at which we were working. And then also the realization that you can only do so much by optimizing, a catalyst or this active surface area. And you have to think about the system approach developing a product and not just a technology. And we were obsessed by solving a problem. When we were thinking about the different products we make, of course, this technology can be used to make sustainable aviation fuels, for example. There's a lot of people actually working on that to solve that problem. Whereas on chemical, which has even a higher barrier to entry, like technologically speaking, there's no one. So we looked around and we were like, okay, perhaps we should actually do that.
Now, one of the things that's fascinating to me about your approach and really excited me about working with you is, I think there's this general concept of scale up. So I need to make something bigger to get economies of scale versus scale out, which is I make a lot of them. And I come from a tech background, so I think of, the computing environment. We used to have these giant, room-sized mainframes, and then we came up with these pizza boxes, and just made a lot of them and put them in data centers. And that sort of scale out approach dominated because you get really good at making those pizza boxes, and each one gets incrementally cheaper as you get really good at making them. And your technology allows you, I would say, more of a scale out rather than a scale up approach. Can you talk a little bit about that?
Yeah. For context, we were mentioning the hydrogenation technologies. These hydrogenation technologies, because they are like high temperature, high pressure, what you want to do in these reactors, you want to minimize the surface over volume ratio because you don't want to lose heat, at the edges. So you need to go very big to ensure this. That's one of the big problems that leads to very high capex and difficulty to actually test new technology for these kind of hydrogenation technologies. In our case, it's very different because it kind of scales linearly. We can not only scale in plane, but also stack more of them. And then once we have a stack, we can also parallelize stacks. And this is known. There is a very old electrolysis technology that is right now used industrially. And, when you go into an electrolysis room, you have 50, 100 stacks in parallel. Each of them have tens of cells. It's a proven model already, and that's a track we can follow to scale up this technology while still proving with reasonable investment early on that the technology is actually going to work.
And then the second is you're building these in a factory, so you get to sort of build serial production. And from what I understand, the membranes can be made in sort of roll-to-roll processes. So these are all things that get learning rates and economies of scale. Is that sort of another advantage of what you're doing?
Yeah, very accurate. And we are also like targeting standardized commercial units. So, then you can parallelize if you need more of that. But all the balance of plant is dimensioned for like a certain size that, it is really helping with the cost as well.
I'm curious. I bet you there's someone watching this who's like in a lab, like, man, I've got this awesome technology. I want to see it out in the world. Take them through a day of the life of the CEO of a deep tech climate startup.
My first obsession is to build the best team possible. I think that's my talent. I think it's all about developing this technology, this company is all about the team. And so as for the team member, where we are looking for like talented, resourceful and this kind of underdog mindset, we are looking for the same in investors, in the sense that we were like really inspired, of course, by your team, and we wanted to really access all these resources in terms of the knowledge of how to build like a highly functional innovation team. There is a lot of IP aspects. I think, it's really very different from software on that aspect, because you can actually lock down some like very strong position that are going to be like 20-year lasting advantages. So you really want to make sure you're there 6 months before everyone. Otherwise, it's a real problem. So this leads me to the thing that I do, which is pushing everyone all the time.
Where did that impatience come from? I'm curious because, I find many researchers are driven by curiosity.
Yeah. It's the obsession about the problem we are here to solve. I mean, David and I, we are like so mission driven. We were every weekend in the lab at Stanford. We were the one reopening the lab after COVID because we wanted to get these experiments done. It's just like an everyday obsession. And that's the main driver for us. And, if we were not doing it as founders, we would be happily doing it like for other company because we just want this to be solved, That's a question of like peace of mind.
What do you hope for over the next 12 months, 2 years? What are you most excited about happening?
We are a very exciting moment. We got a lot accomplished in the past 3 years in this under the radar period of really like hitting technical milestones. We are really transitioning from an R&D intensive phase to a more like industrial prototyping and beginning of partnership and commercialization phase. So it's going to be very exciting to build the team around these new skills and transition from our 70% PhD comprising team to much more like industrial profile, commercialization profile.
someone who's just starting out on their journey here, and what would you love to say to them in terms of advice you wish you had had?
You have an emotional attachment initially when you're a technical founder to like the technology you're building, but you want to embrace reality brutally. Never push a technological path that is not going to work, because at the end of the day, we are in a world where there is a limited amount of resources, amount of capital, and we want to make sure we funnel the money in the right direction.
For people who haven't ever started a company before, it is really hard to get across, A, how exciting and awesome it is, but how hard it can be.
God.
And an experience I had very often was just people telling me either it couldn't be done or I wasn't the right one to do it. I didn't know what I was doing, or so-and-so already had the better technology, or we tried that before and it didn't work. And I'm just curious, has that been your experience? And how do you armor yourself up to be like, nah, that like super experienced person is wrong. I'm going to keep going.
Yeah, I think it's really hard to find the people who advise you. Perhaps the best way to do it is first also look at their track record of successes. I think that's a very pragmatic way, fact-based way to do it. For every doubt we get with Dave, what we do is just like, just keep working. And, that's the best way to find the truth. Yeah, let's do the experiment actually to prove it.
Yeah,
it's probably
but I think that's the
way.
difference between talking and doing. Right? You will definitively find out.
Exactly.
We're making a bet that you're going to build something massive that's going to produce carbon negative or carbon neutral sort of chemicals at a cost advantage to traditional approaches. And like people may doubt you, but we're going to find out.
Exactly. I like to think about when I have doubts. My worst case scenario is that I advance with like the team, we all together advance the state of the art. Thinking that, our team is working on something meaningful and we are making the best use of their time possible.
Yeah. I mean, I think this is like willingness to just try it is this spirit of entrepreneurship that I think you embody. And part of why we very quickly got excited about not just what you were doing, but the way in which you were doing it, and, excited to be along with you on this journey.
Well, thanks, Mike, for having me. Such a pleasure to be working with you. Such an honor, too.
Sarah, thank you so much for...
Let's wait for this play. Sorry.
That was great, though. That was very spontaneous.